Okay, so in this problem here, we have P or Q and not P and not Q. Okay, so this is a two-part problem. The first part is that we have to find the truth table, and the second part is that we need to determine whether or not it's a tautology, taut, tautology contradiction, or neither. So first, let's construct our truth table. First step, count the number of variables in this proposition. I see a P, I see a Q. Therefore, we have two variables, and we always have to raise the number 2 to the power of the number of variables, which in this case is 2. So it would be 2 to 2 power equals 4. So let's create our table. P, Q, look like an A before. Not P, not Q, P or Q. And lastly, wait, no, not P and not Q. And then lastly, P or Q and not P and not Q. So first off, 2, 3, 4. We have our 4 rows. 1, 2, 3, 4. Now, we need, for the first row, this is what I do. I add an equal number of true and false values. So true, true, false, false. Then I alternate with Q so that there's a different combination of truth values for each row. So I'll do false, true, true, false. So we have true, false, true, true, false, true, false, false. Okay. Now, as you can see, they're all different. Now, not P. This is the not operator. In some books, you'll see it like this. At the end of the day, these represent the same concept. This negation operator, it gives you the opposite of the value of not only a variable, but also a proposition and a statement. And there are other mathematical objects to which it applies. But for now, we're just going to worry about this. So, true, opposite true, false, opposite true, false, opposite false, true, opposite true. Same idea with this one except with Q. So, true, false, false, true, P and Q. So, true and false. No, wait. Sorry about that. And is like this. This is or, so P or Q. Meaning that one of these variables has to be true for the entire proposition to be true. So there's a true here. True, 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 false. And this one, now we have to look at not P, not Q. Remind you, this is the AND operator, so both values have to be the same in order for it to evaluate to a certain value. So false, true. This is false since there are neither two truths or two falses. False. Wait, what is this? Oh man, I can't even read my own handwriting. Okay. False, 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 true, false, false, true, true, true. Now we do the last column. True, false, and operator. These two have to be the same. to evaluate to that respective value. True, false, not the same. False, true, false, not the same. False, false, not the same. False, false, true, false. So this is our truth table. Now the second part is whether this is a tautology, a contradiction, or neither. So if we refer to the definitions of a tautology and a contradiction, tautology is a proposition whose value is true for all possible combinations of the truth values of the propositional variables. A contradiction is a proposition whose value is false for all possible combinations of the truth values of the propositional variables. So, as you can see, these are all false. Therefore, this would be a contradiction. And if you saw true, false, false, true, false, true, false, false, true, it will be neither. Because in order for it to be a tautology, all of these have to be true. In order for it to be a contradiction, all of these have to be false, which is the case here. So that's the end of it. If you have any questions about this, feel free to drop a comment below, and I will see you guys next time.